All right, so we left off the other day talking about moraines and all the various moraines that you need to know for the upcoming test. And again, it's not exactly that they're complicated. It's just a lot of vocabulary and words to keep track of, especially when you put those terms on top of the glacial anatomy terms. You guys have a lot of points just in some diagrams. And perhaps it's nice to have some diagram labeling for a change, but nonetheless, we'd hate to see you just slaughter through that, miss it wholesale. So I still do not feel that till is an important term this semester. So, all right, but we do have a handful of other words that we do want to talk about, and one of them is an erratic. An erratic. I mentioned the other day in passing that these giant granite boulders that you'll sometimes just randomly see at places. If you are in the north, like we are, there's a very good chance that they were dropped here by the glaciers. They're very, very heavy things, and oftentimes they're found when excavating to make buildings and whatnot, digging down from the foundation, and it's just, just about as much as these diggers can do to roll it up onto the side and be happy that you want to leave it there as landscaping. If they were smart, they'd start charging by the pound for them. But they are big. And again, to glaciers, they know no bounds. They can carry anything and everything. But the large majority of those is, again, especially as I said, as if it's granite. So we don't have a whole lot of granite around here. But there's plenty of it up north. Now, the other reason this is on here is for the term plucking, okay, which is an official glacial term. Imagine a semi-sentient glob of jello sliding across town, right? Generations ago, there was a movie called The Blob, but I imagine you guys could picture jello at least. And as it would flow over a car, a person, or whatever, it would suck it right up into that. With glaciers, we call that plucking, okay? And that's how these erratics and everything else pretty much are picked up along as the glacier is flowing down. So plucking. All right, we told you it's a big mess in front of a glacier, and the outwash plain, not a vocabulary word, kind of a vocabulary word if you can't put two and two together there and get, stuff is washing out in front of the glacier in an outwash plain, then it's a vocabulary word for you. But the area in front, okay, and we see a number of things going on here. We see some outright just giant flowing streams. We see some trickling stuff. And then we see a handful of what were moraines that are being abused by this glacial wash. All right. And I think you're going to see a handful of these again, but we will introduce some terms that I want you to be familiar with. Starting closest to the glacier here, we've got esker. All right. Then we have drumlins. Then we've also got, what else? Kettles, kettle lakes. Usually we say kettle lake. All right. So eskers, drumlins, and kettle lakes. I think I have a real live picture that we'll switch to talk about these. If not, we'll come back and hit esker. So we're going to talk about drumlins first. I mentioned drumlins you can see along 81 as you're driving south. Quite better, you can see them as you're flying south out of Syracuse to the left and to the right of 81, because from 81 they just look like rolling hills. But from the top, you see that they are elongated and sort of drumstick shape, hence the name. And the neat thing about these is when we find them in the rock record, oftentimes they do get covered over and preserved, or again, they're just still there from the last time glaciers came through in this case. All right, it's not like they're fossilized or anything. They're just hills that have been there for 10,000 years. The neat thing about that is they're tapering sort of shows the way the glaciers flowed, which is kind of neat. We could use it as a, well, in my branch, we call it a paleo indicator, okay? Paleo means ancient or old, and it's a clue. Right? You guys grew up with like CSI and stuff like that on TV. It's a clue at the crime scene that we can use to reconstruct the past. All right. So the gentle slope is in the flow direction, and the steep slope is uphill. You know, up the way the glacier came from. So the gentle slope is the way it was headed. It's a better picture here. And so this is moraine that was laid down in front of the glacier. It decided to move forward again. All right, and it's the groundwater flowing underneath oftentimes that shapes these things. It isn't really clear about saying that, but that's what's going on. Told you there's a lot of flow underneath these glaciers, especially when you're down by the end. I don't know how well you guys read contours. You don't necessarily need to in order to get a feel for this, but you know, this is more or less what's going on here. We've got these little hills. They're oval shaped. They're elongated, however you want to say it. And as you can see, they're all kind of narrowly tapered in one direction. So, and this is probably what something along the lines of a topo map just south of Syracuse would look like. So Esker, mentioned Esker a couple minutes ago. This is again a reworked moraine, but this one has the shape of a snake. Esker, if you drag the S out, it kind of sounds snaky. And again, this is just from the water flowing underneath it. It leaves a trail, if you would. Yeah, I don't know necessarily that they're following it all. That's an interesting question. I'm not sure that they're following any old pathways or not. Again, it totally depends on whether or not the glacier's already plowed forward and then moved back. If it plowed forward, you know, there's a good chance anything that was there is destroyed. But not always. You know, the Finger Lakes are a great example where they were actually dug out instead of filled in. And, you know, I think it just has to be a matter of happenstance, what happens each time. They were fairly long streams. We know that they think that they went all the way up to Lake Ontario. But with regard to excuse me, how big or wide or anything like that, I'm not, you know, familiar with that knowledge at any rate. So, but yeah, they certainly could at any rate. But more so, it's just, you know, randomness. And here's an idea of what it might, you know, part of one might look like. So in retrospect, you know, you could go back, and I'm not officially adding this to our list of moraines, but you may find a good-sized vertical mound that snakes along, mixed in with your moraine, and you would definitely then find, you know, that would be an esker deposit. So, again, this stuff can get left behind in the record. So Kettle Lake is really the last thing we have to talk about. And a Kettle Lake is named for its shape, okay? Round, steep, and deep. And if you've had the opportunity to head out to Cape Cod, any of the inland lakes are Kettle Lakes out there. Cape Cod is highly glaciated. I don't think I've seen any of these, but a fellow teacher used to go, and he loved that so much more than going to the shoreline. I was always a shoreline kind of guy, even though it's, you know, frigid out there if you've been to the Atlantic side of Cape Cod. But he always preferred these kettle lakes on the interior. And what happens is, as the glacier's melting out, oftentimes these one of two things happens. One, a giant chunk of ice can fall off, right? And that's the typical way they tell you the kettles form. And they dig a big old hole in the ground, and then it fills in with water over time. Well, when the ice melts, but it has to continue doing so. And then also sometimes these giant erratics. But if the boulder, was still in the way, obviously it wouldn't be a lake. So that one is at least for me. I don't want to say I never fully believed what they said, but it's hard. It's difficult for me to picture a kettle lake forming. So, but big, round, steep, deep lakes. These are really neat. These weren't on the previous slide. And in this image, it might be very hard to see them. We're looking for these very light striations moving more or less from left to right across the screen. They're a little tilted. They're called glacial grooves. And going back to the idea that the glaciers pick up big hunks of rock as they flow, they can drag them along and gouge out whatever it's sliding along. The problem with these is they're not as big and prominent as moraines. Someone might notice them, but not really even think much of it. And so we don't have a whole lot of them left. There's a few places. I'm not even sure of any around here, but we had some in Ohio in a couple places. I've got a picture of a really good set right here up on Kelly's Island. It's a lake in Lake Erie. It's an island in Lake Erie. And these things are huge. You could run a toboggan through these. And it's a small stretch. It's maybe 100 feet by 50 feet or so. And when they were developing there, somebody knew enough to call an engineer or whatever and say, hey, what's this weird stuff we got? And they preserved it. It's if not national heritage area, it's a state heritage area. But a much smaller level as well, you can see these. There was a set of rocks on the campus where I went to that had some glacial grooves in it. So they're around. You just, like I said, oftentimes they're so subtle you don't notice them. These not subtle here. We talked about the term calving earlier. It showed up on another slide, and when I mentioned that I can't see these forming kettle lakes, they can be quite huge. Okay, don't get me wrong, but typically when we talk about icebergs forming, we think about already in water, right? So the idea of a chunk of ice breaking off the glacier, it's a little different context. This one also has something kind of cool in it. I don't use it as a vocabulary word for you guys, but it is a neat phenomena called drop stones. And again, what happens is as the iceberg breaks off and if it goes into the water, it starts to melt. And all these little pebbles that were plucked previously start to fall out, and you get this sort of little confetti of little stones that are randomly dropped in front of the glacier area there. And again, that could get preserved in the sediment record as well. But calving is the term for icebergs breaking off, if you missed that the first time through. And my favorite, just because I like to say fja, but fjords. Fjords. Fjords are inundated glacial valleys. Inundated is a fancy word for flooded. All right. And I like this for a lot of reasons. One, they're very pretty. Two, they were a great sort of ambushy military sort of place back when we invaded people on boats and poured vats of tar and boiling oil down on them kind of thing. And 3, and quite most importantly, they are serious, serious evidence that the shorelines used to be a lot farther out. Okay. So what we see here is that, here's a great example. Okay. And right now, sea level is higher, so this old valley is flooded in. Okay. But when the glacier was coming through, there was no water there, and it carved its way all the way down to the existing coastline at the time. And these are often quite deep. They can bring cruise ships into them, kind of thing. They're pretty deep things. So it's a good bit of flooding too. It's not just, you know, they're swamped in now kind of thing. They can be quite deep. And picturesque, again, I mentioned cruise ships. I know there's a handful. That's not something our family's ever done, but, you know, for scale, here's a village down there. So they come in, they tour for a little while, they turn around, go back out. You see these over in Northern Europe a lot. It's a Scandinavian term. All right, so that's sort of winding up and segueing at the same time there. The last sort of vocabulary, glacier vocabulary word. But it gives us one more time to reiterate the idea that water cycle, okay? We only have so much water on the planet. We more or less have always had the same amount of water. We more or less always will have the same amount of water. It's just where is it at any given time. So, during the last glaciation, what are we trying to show here? Last glaciation, yes, I see that. We've got the Great Salt Lake, Lake Agassiz, Winnipeg. Okay, very faint lines. Here's what I knew there was a reason to have this up other than just to show you guys the lakes that used to exist. You see these really light red lines in here. These would be your terminal moraines, so to speak. Okay. And I wish they'd picked a different color. I'm not sure how well. They're showing up much better on the screen here. My laptop's kind of washing them out for some reason. Hopefully you guys on the recording can see the red lines here. And so, you know, these lines are marking the farthest that the glaciers came through back in the last glaciation, which we'll tell you all about that in a moment or two. Since it's on here, we'll also show you these purple areas. These were some ancient lakes that we had. Again, we can tell because we see these lake deposits. We can see the old shorelines. Lake Bonneville is one they love to talk about because Salt Lake is what's left of that. And you've got the Bonneville Salt Flats. If you know anything about the area out there, if you follow car racing, they like to bring cars out there to land speed record kind of stuff because it's way, way flat. Anywho, so this was a very, very, very large lake, and Salt Lake is just a remnant of what was. Here's another view of the last glaciation. And what this one adds is not just the top view, but it takes away well, it doesn't take anything away. It adds where the old coastline was, okay? That's a lot of addition. That's a lot of addition. If this were, you know, scientifically accurate, which I'm guessing it's not precise, for example, there would be Florida and Cuba would be touching, okay? But don't quote me on that. Don't quote this diagram on that. But just to give you an idea, what do they say? It's like 90 miles to Cuba, I think, off the farthest tip Florida, something like that, or maybe it's off of the last key. It's 90 miles. But, so, you know, like I said, we just see that everything that was covered in ice. Definitely the Great Lakes. We see, you know, Cape Cod, we were just talking about that, is underwater. Manhattan, not underwater, under ice. Manhattan's under ice. And large portion of Europe and Asia underwater as well. I keep saying underwater. You know what I mean? Under ice. Under hard water. So the Finger Lakes, I can't name them. You guys can, right? So you grew up with this stuff. Oops. But it's a lot easier to see here that at some point in time these were streams that went all the way up. All right, so now we're going to talk about the other direction here, and we've got a lot of lines on this map. Here's the old one that shows the coastline during the last ice age, which we just approximated for you. And you see here where it is not really anywhere near Cuba. But this one is more to show you if the ice continues to melt, if we head into this this in-between glacial period, where the flooding, where the inundation will move to. Okay, and you see Long Island, for example, here is completely... All right, so anyhow, unpausing here. So we see a lot of coastline lost. And, you know, it's a prediction, all right? It's a prediction made on a handful of things. It's a prediction made on what we feel the volume of ice above water is. And we're looking at topographic data of the continents. Again, when you're at the coast, oftentimes there's a good bit of distance that you can go in vertically. Horizontally, whatever the word would be there, not vertically though. Where you just don't have a whole lot of elevation change, okay? And I think we noticed even here in Utica, we're not that horribly far above sea level at all. So, you know, a good bit of anywhere you go to vacation on the East Coast will be under. It's kind of hard to get your bearings here, but as to where the states were, I wish they kind of did an overlay, you know, other than the obviousness of Florida there. But, you know, half of Georgia, half of each of the Carolinas at least.
Some of Texas.
Yeah, definitely some of Texas there. Much of Mississippi, you know, Alabama. But, you know, it's an artistic interpretation, but it's a good idea of what can happen. So, and this is just us. All right, there's so many other places in the world. You guys know that, but there's so many other countries that are even in a worse predicament than this. So, Netherlands is one that comes up all the time. Italy, Greece, anyone along the Mediterranean. Yeah, Japan, China, up and down that coast as well. But yeah, there's a lot of changes. So when was this? Well, the term at the top there is Pleistocene, okay? And Pleistocene is our most recent time period. And it's the one that you see in all your cartoony movies there. And this is when our most recent ice age occurred. It started about just under 2 million years ago. And it went to, again, depending on where you are, anywhere between 10 to 12,000 years ago. This 11,700 is awfully specific. But I stand by what I've said. The farther south you were, generally speaking, the longer ago it disappeared. But this is a decent average. I don't think I have a slide for it, but I do want to touch back on the conversation that came up the other day about whether or not we ever left the Ice Age or so on and so forth. So we'll go through what slides we have left. The neat thing about the Pleistocene is it was a really great time to be a mammal. And most of the large mammals that you guys know about, be it the mammoths and the other guys that just jumped out of my head here, mastodons, and yes, the saber-toothed tigers and all of those wonderful things. This was pretty much the end for them. For one thing, humans were really starting to bloom as well. We're mammals too. And a lot of that was indeed hunting. But they were used to these temperatures. They had a couple million years with which, if they wanted to live up by the glaciers, the mammoths, for example, you really don't want to have those that fur coat on in Florida, right? The mammoths and whatnot. The woolly rhinoceros you see here as well. We also had horses. A lot of people know about horses, that they were brought here by the Spaniards. Well, we did have them originally. All right, my project in grad school was on zebras, which were in Nebraska. So, we had all these critters, but they died away. And when people say they weren't native to here, they mean since we've been keeping, records. And from a human perspective, they're not native. And they're right. They were long gone. But we were here hunting. Okay, we just weren't keeping very good encyclopedias at the time. Well, we had drawings and whatnot. This is sort of your cave drawing time period. I don't get too much into the anthro end of things, but that's a really fun. Your letters and your numerals and well, yeah, but that is to put a plug in for anthro. If you enjoy learning about early humans and civilizations and cultures and stuff, that's a fun class. It's a fun class. And it's kind of where historical geology leaves off, because we tend not to focus on humans. We lead up to pretty much these guys, But so we were here hunting, doing our thing, and the glaciers were melting back. And it's not just, I'm not going to paint hunting as the evil demon here, of course, bless you. We certainly were it's sustenance at that point, right? We didn't have freezers and whatnot, except for the glaciers, I guess. But we ate what we hunted what we needed. But as I said, our population was also blooming. But there's more to it. There's the climate change, as I started to talk about. The glaciers retreated for a reason, okay? It just wasn't the timer that was done up. The atmosphere changed, the weather changed, and it was no longer feeding the glaciers enough to maintain them, so they shrank back. And with that, other weather patterns changed. And it was just a different world, and it was hard to be a giant furry mammal, harder than it used to be, at any rate. But this is one of my favorite halls. If you guys ever get to Manhattan, there's so many things to see there, I know. But on the Upper West Side, across from Central Park, is the American Museum of Natural History. And they've got a wonderful Cenozoic hall, ancient mammal hall. And to see some of these things, how big they were. And just to see a saber-toothed tiger in person is kind of cool, too. But so many other things, the giant sloths and whatnot. Amazing. You could just go to Albany and see a mammoth, a mastodon, if you haven't yet. They used to have them on display in the State Museum there. And those are part of New York State's history right there. We found 2 or 3 in New York State. Cohees mammoth, and there's another one. So that wasn't that long ago. I know it seems like forever for you guys. And, we have kind of this, as humans, we have this weird time frame. If you're not involved in science, you've got like your grandparents, and then, well, whatever it was that black and white photos were, and then maybe there was cowboys and Indians, and then, I don't know, Egypt was doing its thing. We kind of jump from these cultural landmarks that we have from TV and history in our brains, and you oftentimes don't realize how far back you are going. When you get into talking about Egypt, you're in about halfway to this ice age at that point, to the end of it at any rate. Because you're definitely back. I know they don't use BC anymore, but you're definitely back into 6,000 BC. Yeah, whatever. In geology, we say before present. So, but not everyone knows that one either. Years ago, I still like years ago, but because people have with before present, years before they always forget to put the 2000 in it. So if they go back and they say, 12,000 years before the present, so it was 12,000 years ago. No, it was it was 10 because you got before it was 10,000. It was 10,000 BCE, not 12,000 BCE, because you forget about the 2000 that it's 2023 now. That's what I meant, regardless of what I said. Yeah. But so you don't have to do the math if you say it the other way. And that's the problem with BC. If you say 5,000 BC, they forget to add 2,000 years onto that, so it was actually 7,000 years ago. So I think that's why geology, they just decided to hell with it and say years ago, or years before present, I should say. So it wasn't that far long ago, at any rate, was my point. And I'm not giving Hollywood any credit here for saying that they still had mastodons and whatnot roaming the planet then, and we used them to move stuff. I forget I think I maybe just saw the mummy, the Brendan Fraser mummy, a while ago, and they had mastodons hauling giant limestone blocks to help build the pyramids and whatever. But, here and there, extinction isn't a split-second thing. Extinction takes time. So there may have been pockets here and there. You never know. We are no longer in the Pleistocene. We are in the Holocene. All right? And this is post-glacial, modern humans. Everyone's familiar with Homo sapien. Well, technically, we are Homo sapien sapien, a subspecies of Homo sapien. That is basically modern human. We have changed in the last 10,000 years or so, 15,000 years. There's no question about that. A quick trip to the antique store shows you that even 100 some years ago, people were a lot shorter than they are now because all those tables and chairs are made so small. So we've changed a number of times at any rate. Again, this goes into another field, but so we won't talk about it too much. But the one thing I do want to talk about is this post-glacial, because I do think this is our last slide there. So when you really back up and look at the rock record or the Earth's record, we see these periods where the glaciers advance and retreat as part of a cycle, a very large cycle. And the periods in between are called interstitial periods. And allergy season. And they will be fairly quick to point out that the average interstitial period is longer than the amount of time we've been out of, in quotes, this current glaciation. Okay? The point being, if you didn't follow me, is that for all we know, we are in an interstitial period. Okay? Or we're supposed to be. And that the glaciers would have come back down and so on and so forth. What we can add to that is, again, based on the data, we have air bubbles that we've looked at trapped from ice cores and so on and so forth. is that we are changing the atmosphere in such a way, we'll be fair and civil, the atmosphere is changing in such a way, I won't say we're doing it, in such a way that we potentially will not go back into that glacial period of glaciation if we were, in fact, in an interstitial. You guys in your history classes may have heard of the Little Ice Age. It was Revolutionary War-ish time, when there was a period of time where the winters were just miserable, unbearable. And I think that's back when the Thames used to freeze over as well, big river through London. That may have been it trying to kick in. Who knows at this point? But thanks to the Industrial Revolution, there I went and did it again, blaming it on humans. But once the Industrial Revolution kicked in, seemingly we have chosen a new destiny. So, fine by me. I'm no fan of glaciers, don't get me wrong. I like warmer weather. But nonetheless, we'll see what it brings up. So that, I don't know if that's an answer to your question from the other day or not, but there is such a thing as interstitial periods, and we've measured those cycles, and as I said, the 10 to 12,000 years that we're looking at now is just a smattering in there. So much of this stuff is such bigger cycles and systems than humans are used to measuring. We think of it at most, as I was half joking earlier, we think of generations, a couple generations back. And that's fine. That's where our brain works. We're so tied up in, we have to be on time for work, on time for class. We have a bill due tomorrow, and so on and so forth. We're in a very short time period kind of world. It's an immediate world. And even more so in the last 10, 15 years with cell phones and Amazon and this, that, we've gotten even more lickety-split.
And even more so compared to the entire Earth.
You could certainly say there's areas that are more so than others, yeah, that's for sure. And I, of course, speak only of us, but I don't often have a very worldly view, and I should. But yeah, I'm referring to Americans in general. And don't get me wrong, again, I'm not bad-mouthing it. I love my Amazon Prime as much as anybody. I'm not a patient man. But they're just, we're just kind of making it worse for ourselves. But, all right, it's not philosophy class, right? We'll let this one go. I guess you can't not talk about environmental science and stuff like that without. I think we started by talking about environmental philosophies, actually, in retrospect.
Yeah, but this isn't a fully glorified philosophy class. You don't know too much on it, right?
Yeah, it's been a long time since I formally had philosophy. Can you guys even still take that as an elective? Intro to philosophy? Probably. I'd say that's a no then. Yeah, in a 4-year, but that was a fun class. Fun class.